Okay, welcome back. Today, we're going to be learning the basics of raster data, some of my favorite stuff to work with. Raster data is really cool because there's so many different things that you can store. That raster data will tell you, about land cover and attributes of the land surface. If you have not done it, go ahead and download the data for this lab. I've got mine stored in Lab 12 data. And then go ahead and unzip this file. This is a pretty big set of data, so it may take you a while to down or extract it. So make sure you allow for that time. So while that's going, I'm just going to go ahead and minimize that. Make sure that you are open in a new blank. You have a new blank map open over here. Make sure that you're in data view. If you were in layout view, it'll look like that. Let's come on over to data view. So next, what we're going to do is we're going to add the three raster files. And if you remember back at the beginning of the course, we learned about differences of raster data and vector data. And so we're going to add the three raster files. There's a variety of ways you can do that. I'm going to use our catalog to do that. And so I downloaded it in Lab 11, Lab 12. Data, here, and then here's our three raster files here, and I'm just going to add them one at a time. There's Denton 2001. If I'd stop double clicking on it, here we go. Denton 2006, and then Denton 2011. Pretty weird, funky looking stuff here. These colors all represent something, okay? Trying to figure out how we would want to get into this. Okay, so your colors are assigned randomly here in ArcMap. The colors don't mean anything right here, and it doesn't look the same as your as what's in your instruction. Because of that, not a big deal. Don't worry about it. Just remember that this color here represents a part of the map, a section of the map. We can see that 11, it kind of looks like it's going to apply to Lake Louisville here, right? And then, like 21 would represent, it's somewhere down in here, right? Matter of fact, I'm going to zoom in on this a little bit, just so we can see it better. Zoom to layer. I don't like that. Here we go. Okay, so in the instruction, it gives the National Land Cover Classification Legend. You don't have to pay attention to the colors on it. What you do need to pay attention to is the classification type. And I've got it snipped right here. 11 applies to open water. 12 applies to perennial ice / snow. And all the way down. 95, we're not worried about this color. Remember, because the colors can change. The colors are going to be different. What we're worried about here is the number here, and then what it applies to. 90 applies to woody wetlands. 82 applies to cultivated crops, right? Okay, so we have this right here. I'm going to minimize this. I'm going to right click on properties, and we can get some information about this raster. Now we see here that the cell size is 30 by 30, and that means 30 meters by 30 meters. I'll explain to you what that means. if we were to zoom in very, 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 very close to this, each pixel, let me zoom in even closer. This pixel right here is going to be 30 meters by 30 meters. This measurement literally is 30 meters this way and 30 meters this way. And we can even measure that using our measure tool. Click that, we'll come across. Well, it's in kilometers. Distance meters. Here we go. Okay, so we can see that that's 30-meter distance. I mean, that's as close as it can get right there. You know, I'm not going to go in and show you that, you know, take the time to go to 30 meters. And we come down and we see this, and it is literally 30 meters. Each cell, each pixel is 30 meters. And so that's what that cell size means. Whenever we go into here and we look at the properties, it says cell size 30 by 30, X and Y. It's 30 tall by 30 wide, 30 meters. We know that it's meters because well, if I can find it, that's not what, I'm sorry, I'm trying to move through these things here. Linear unit, meter. So we know that, you know, the linear unit it's recording in is in meters, 30 by 30. The cell size is 30 meters by 30 meters. I hope I've spent a couple of minutes on this, so I hope it's in there. So you can examine the properties and find the cell size, you know, in the linear unit. And that's exactly what the what some of your questions will ask later on is to be able to do that. Step 4 in our instruction has us right-click the raster layer, and I'm going to zoom back out to that and open the attribute table. And so let's look at the attribute table for this. And what we have here is row ID, which you don't have to worry about, value, and count. Okay, so the value, remember we had this legend right here, right? We see that 11 applies to open water. That's the value right here. So you have every value on here that applies to 11 is going to be open water. So you don't want to look at the color, you want to look at the value. And here's what we can do is that I can select that right there, and we can see every pixel that has a value of 11. And we see that it's this water right here, right? If I wanted to look at 21, let's see what 21 is. 21 is developed open space. So if I wanted to see the pixels that represent 21, we'll select it just like that. And this is developed open space. Let's look at 52. What is 52? 52 is shrub and scrub. It's not very much of it. We can see this has a low count, and I'll explain count in a second. I can barely see any of it. And that's because there's only 934 of those pixels that represent, you know, that area in here. Let's do one more. We'll take a look at 71, right? 71 is grassland and herbaceous. So we'll click this right here. And all of the selected area is considered grassland and herbaceous land cover. Now, we've covered values. Let's talk about count. Count is nothing more than the number of pixels for this value. So, if we were to go back up to number 11, we said this was open water. 11 represented open water. There are 227,610 pixels that represent open water. For number 21, let's see what that is. 21 is developed open space. For developed open space, there are 186,400 465 pixels that represent develop open space. For number 22, that's develop low intensity. 185,583 pixels represent show develop low intensity, and so on. You know, for 52, shrub and scrub, we see that only 934 pixels are in here. So the greater the amount of pixels you have here, the more space that it occupies on here. And we can see that by let's select 12 and see what that looks like. Yeah, we can see that 12 just kind of has some of this stuff here, or I'm sorry, not 12, but 90. What is 90 represented by? Woody wetlands. And so you're going to find that, you know, around your wetlands, near the lakes, and a little bit right here, I guess, too. But we see that it's only represented by 18,265 pixels, right? If we did that for 13, or I'm sorry, not 13, but 95, there's a smaller amount of pixels. So you can alternate between those two. And you can visually see that it's represented by this is represented by a smaller amount of pixels than this one. The greater the amount of pixels, the greater land coverage type you have. So, that's pretty easy stuff. And just take a look at it, kind of click around in it, figure out what we're looking at. So, question 1 of the instruction asks you, what's the cell size of the rasters? I've already showed you how to do that. Same thing goes for question 2. What is the linear unit of the rasters? You know, it's going to be in miles, kilometers, chains. I've showed you how to do that. Question 3 asks, what is the dominant land cover class for Denton County for 2001, 2006, and 2011? So what you'll want to do is for each of these, you'll want to open the attribute table, you know, for this one, and open the attribute table for this one. We've got all 3 of them down here, so you'll want to write down the dominant land cover class, and that's the, you know, what land class covers the most amount of area, the dominant land class. So you'll want to figure that out for 2011, 2006, and 2001. The next question asks, what is the area in square kilometers of deciduous forest in Denton County 2001? What you need to do is just, you know, we'll see what number that goes with. It's 41, right? And so we know that these are in meters, and it's asking you to find it in square kilometers. So you're going to have to do a little math on that. You're going to have to, you know, figure area, you know, and then how many pixels are represented by that, and then convert it to square kilometers. Really, you know, really simple, you know, high school geometry. And that's actually question 4, 5, and 6. I mean, you just do it all the same way. And then question 7 is going to ask, describe the changes in total area of open water in Denton County from 2001 to 2006 to 2011. And really all you need to do is just go into your attribute table, look at the count, and be able to say how those numbers changed. Did they increase? Did they decrease? Did they stay the same? So you want to take a look at that and how the number of pixels has changed over the years. Really simple work. There's no deliverable for this, so you don't have to do any layout, and that kind of wraps up what I have to say. I think this is very cool stuff, but it takes a little bit to get used to. There's many other applications for raster data, and this is just, starting to get into the basics. Um, but as always, if you have any questions, give us a call or give us a holler, and someone will be there to answer them for you.